I want to create a clip on the basics of earthquake engineering on YouTube. To withstand earthquakes, structures must be designed to properly withstand seismic forces. This design includes things like dynamic analysis, earthquake simulation, designing a column beam system, and support systems, as well as creating complexity in the structure. Additionally, engineers must consider factors such as the location of the structure, the height of the structure, and other aspects such as performance and safety in the design of earthquake-resistant structures. As a result, earthquake engineering is crucial for buildings and cities, and this should be taken into account at all stages of the design and construction of structures. We hope this clip helps you become more familiar with the fundamental concepts of earthquake engineering.
Earthquakes are caused by the sudden release of energy that has built up within the Earth's crust. This energy is released in the form of seismic waves, which can cause the ground to shake violently and lead to significant damage and loss of life. There are several factors that can trigger an earthquake. One of the most common causes is the movement of tectonic plates. These plates are large pieces of the Earth's crust that move slowly but constantly. When two plates collide, one plate may be forced under the other, or they may slip past each other. This can cause a sudden movement of the Earth's crust and result in an earthquake. Another common cause of earthquakes is volcanic activity. When a volcano erupts, it can cause significant seismic activity. This is because the movement of magma and gases beneath the surface can cause the Earth's crust to shift and lead to an earthquake. Finally, human activities can also trigger earthquakes. For example, the construction of large dams or the extraction of oil and gas from the Earth's crust can cause small earthquakes or even induce larger ones. Overall, earthquakes are a natural phenomenon that can have significant impacts on human populations. Understanding the causes of earthquakes is an essential part of earthquake engineering and can help engineers design structures that are more resilient in the face of seismic activity.
The theory of plate tectonics, also known as the theory of continental drift, is a fundamental concept in the field of geology. It was developed in the 20th century by geologists and other scientists, and has since become widely accepted as the scientific model for explaining the movement and behavior of the Earth's crust. According to the theory of plate tectonics, the Earth's outer shell is composed of several large plates, or pieces of the Earth's crust, that move and interact with each other. These plates can be made up of both continental and oceanic crust and are in constant motion, driven by forces deep within the Earth. The movement of the plates can cause a range of geological phenomena, including earthquakes, volcanic activity, and the creation of mountain ranges. For example, when two plates collide, one may be pushed under the other, causing the formation of mountain ranges and volcanic activity. When two plates move apart, magma can rise up from the mantle, creating new crust and potentially leading to the formation of oceanic ridges. The theory of plate tectonics has helped scientists better understand many aspects of the Earth's geology, including the distribution of earthquakes and volcanoes, the history of mountain building events, and the formation of the Earth's continents and oceans. Overall, the theory of plate tectonics is an essential concept in the field of geology and has provided a framework for scientists to better understand the behavior and evolution of the Earth's crust over millions of years.
Come along with us to enjoy the perfect combination of engineering knowledge and nature's delights.
Today we'll be talking about earthquake-resistant buildings. An earthquake-resistant building is designed to withstand the force of an earthquake and minimize damage to the structure and its inhabitants. There are several key features of earthquake-resistant buildings, including strong foundations. A building with a strong foundation is better able to resist the shaking and movement caused by an earthquake. This is why earthquake-resistant buildings are typically built on solid rock or soil, and not on softer or more unstable ground. Flexible design. An earthquake-resistant building is designed to flex and bend during an earthquake, rather than remaining rigid. This can help to distribute the force of the earthquake throughout the building, rather than concentrating it in one spot. Strengthened walls and columns. The walls and columns of an earthquake-resistant building are typically reinforced with steel or other materials to increase their strength and ability to withstand the force of an earthquake. Dampers. Dampers are devices that are installed in earthquake-resistant buildings to absorb the energy generated by an earthquake. They work by converting the kinetic energy of the earthquake into heat, which is dissipated harmlessly. Emergency systems. Finally, earthquake-resistant buildings are typically equipped with emergency systems, such as fire suppression systems and backup power generators.